Now, you're all wondering, what happened to 550? Let's talk about that. You remember how we talked about the difference between discrete and continuous? The normal distribution, it's continuous. It's nice and smooth. Normal distribution is supposed to be for things like people's heights and weights, continuous random variables. But this binomial distribution, it's discrete. You know, if you have 5 kids, 3 of them might be girls, 2 of them might be girls, 4 of them might be girls. You aren't going to have 3.7 girls out of 5 children. It's a discrete variable. So, when we use a continuous distribution to model a discrete variable, it doesn't always work out smoothly. So we need to correct for continuity. We want fewer than 550. So that includes 549, sure. Does that include 550? No. So we don't include 550. And we stop at 549.5. Another way to think of it is that it's all the numbers that would round to less than 550. If you say, okay, I'm 5 feet 7 inches tall, well, you're not exactly 5 feet 7 inches tall. You say that you are if your height would round to that. If you're anywhere between 5'6.5" and 5'7.5". So anything more than 549.5 would round to 550 or more. Let's do a few examples of how you would just do the correcting step, because honestly, this correcting thing is the hardest part of using the normal approximation. The rest of it is like really quite simple. So, if a problem said 12 or more, what value would you use? You can't use 12. It's got to be a 0.5. I like to use the number line. The phrase 12 or more, does it include 11? No. Does it include 12? Yes. Does it include 13? Yes. Oh, okay, so the cutoff is supposed to be between 11 and 12. I should use 11.5. What if it said more than 12? More than 12. Is that 11? No. 12? No. 13? Yes. Oh, okay. So we're supposed to cut it off between 12 and 13. Use 12.5. Okay, how about less than 12? Is 11 less than 12? Sure. How about 12? No. Okay. Use 11.5. And how about 12 or less? Well, that would include 11 and 12, but not 13. Starting to make some sense? Good.